Hi everyone. Are you guys ready for the closing talk today? So I would like to introduce you a topic that's really interesting and also my current pain point at the moment. That's your data is late again, handling late arriving data in the modern data stock. And we will have a speaker today, it's the Hwee. She is a senior data engineer at Raf, and her favorite ice cream flavor is pistachio, the good ones. So are you ready, Hwee? It's your day now.
Hello, can everyone hear us? Can everyone hear me? Loud and clear? Yes, you better be, because your data is late again. Yeah, and it's not a joke. Your data is late again. So about me, thanks for the intro. I currently serve as a senior data engineer at Grab, namely for the Indonesian digital banking use case. I am a speaker and a very occasional writer in my free time in data engineering topics, mainly because you have a lot of pain points when you're working in this field, right? So you gotta write about it. And a little bit about my background, I am 90% self-taught with the 10% from my engineering degrees. But then again, a lot of things are self-taught nowadays because everything in data engineering is self-taught. Well, before we go into the topic, let's set some ground expectations. So whatever insights in this talk are based on my experience and war stories, it doesn't represent my employer in any form. And any coincidence, any similarity from any real events are purely coincidental, so don't shoot me. And the prerequisite for this talk is that you need to have a sense of the concept of time in data. So anybody doesn't have the prerequisite? Okay, then I shall continue. When we talk about the latest data in the data warehouse or the data lake, which timestamp are we really referring to? Is it when the data even happened? Or is it when the data reached when the data was updated in the source? Or is it when the data actually reaches your data warehouse or data lake? Tricky question, right? So let's imagine this scenario in your data team, which happens to be an almost everyday occurrence. So you have a data pipeline that ingests data every hour. You have a customer data, you have a transactions data, and your customer data needs to be joined with your transactions data because otherwise, we don't know who made the transactions, right? And we need to know who made those transactions to be able to conduct some transactions monitoring and also to know if there are any bad guys who are exploiting your platform. Well, the bad news is you have an outage. I'm not going to mention what kind of outage, but this outage caused the updated customer data to arrive 3 hours late when your transactions data has already arrived. So, what are you going to do? Are you going to just let those transactions data with the new customers, without the new customer information, flow into your report? Tricky question, right? So your data team's objectives are, number one, you want to ensure timely and accurate reporting for your business users. Otherwise, they're going to be angry. You want to include those late arriving data in your monitoring reports because otherwise, they're not going to know any bad guys who onboarded on your platform and and are doing some shady money laundering stuff. And because you are sort of in a regulated industry, you also need to maintain audit log of your data changes for data governance purposes. And that's a lot to handle, right? Now, to start off, we need to remember that time is an important dimension in your data. And it's usually not static. It changes over time, and it's not just about your transactions. Your attributes can also change over time. And speaking about the concept of time in data, we need to look at a few dimensions. It is not just about one-dimension time. For the scope of this talk, we are looking at two dimensions. So first dimension is what we commonly know as valid time, also known as the event time or the actual time that the event happened. And this time is mutable depending on which state your data is currently in. Now that's the time that we are used to about the event time. Now we have system time, which is also known as a record time, or those who call it transaction time in the database. Not so much about the transaction time in the real world. This is a time where your data for that event is recorded in the system. And this is immutable by default, because once it's in the system, it's in the system. And your event time may not be equal to your system time. And did we mention about the modern data stack that we work with? Take a moment to appreciate this picture about our modern data stack. You have your data sources from your databases, your APIs, your S3 buckets, and then you load those data with a data loader into a staging area in your data warehouse. So this pattern is also known as ELT, extract, load, transform, whereby we are extracting and loading the data in the data warehouse before you do some transformation. And then you need to do some orchestration, cleaning up, and so on and so forth. And if you look at this data stack, and the time that it takes for the data to flow through every component in the stack, this is where it gets a little bit trickier. So what do we mean by system time? So in the data platform, your system time could be your source system time, your ingestion system time, or it could be your data warehouse or data lake system time. So what system time are we referring to? See the problem now? And if you look at the data stack, there will be data latency in between those steps. And there might be multiple causes that causes your data latency. So it could be your latency in your upstream system, whereby it does take time for your event data to be inserted into your source system. It could be network delays during the ingestion, whereby when you're trying to ingest data from the source system, you face a network communication error. Or it could also be that you have an out-of-order event generation, whereby there's some problem with the insertion of your event data into your database. And this is the sort of challenges that results in us having to deal with change data capture to try to capture all those changes in all your sources, because shit happens. So, what is change data capture, you might ask? Think of it as data versioning for databases. So if you've used Git before, think of it as Git for databases. And this is a design pattern for capturing and tracking changes in data over time from the upstream source, because you want to capture every single event as much as possible so that whatever that is in your data warehouse is in sync with your upstream source. Now, change data capture is not quite new, though let's focus more on change data capture in the modern data stack. We have our modern approaches, such as data snapshots, because storage is cheap, right? Just snapshot all your data. But hey, besides snapshotting all your data, you should also control for performance, so you have incremental models. However, it doesn't mean that your traditional methods are useless, because we still have the concept of slowly changing dimensions, which are still relevant when you're doing your data modeling for change data capture. Now, what are data snapshots? Think of it as taking pictures of your database in very frequent intervals. Let's say every 5 minutes or every hour. Depends on the resolution of your capture. What are incremental models? So to put it simply, we are only taking the incremental load difference between what is already in your target and what it needs to be processed from the source. And then you take the difference. And if you have not seen an incremental model before, typically how an incremental model looks like is that you assume that you already have some data in your destination. You look at what is the latest timestamp in your destination, and then you determine the condition for that incremental load. Okay, now we've talked about the modern approaches. Let's talk about the not so modern approaches, which are still evergreen and relevant. What are slowly changing dimensions? Now because this is not the main subject of the talk, let's briefly run through a recap of what are slowly changing dimensions. The slowly changing dimensions are basically your dimensions data, whereby you want to capture changes in your data over time. For simplicity, let's focus on two main types. We have type 1, which are usually used for fact tables, whereby you take the updated data all the time, and any previous version of the value is overwritten by the latest value. Well, you will have some history loss, but the thing is that, do you want to capture all the history? Oh, if you want to capture all the history, you have type 2 slowly changing dimensions, whereby you implement row versioning for each dimension over time. And when we are going new into type 2 slowly changing dimension, also known as type 2 SCD, there is an important concept called the validity period for each record, whereby you have the effective date, expiration date, and whether the record is currently valid or not. And it's currently implemented using tuple versioning. For those who are not familiar with tuple versioning, here's a quick view of how tuple versioning looks like. Okay, so how does tuple versioning work? Yeah, imagine this is the current state of your data warehouse, and there has been a change in the customer tiering. Now look at the next slide. Now you have a customer whose tiering changed from tier 2 to tier 1, and if you want to capture this change with SCD2, you will need to update the previous record before you insert the next record. And in this case, you are not overwriting the previous record. You are simply updating the previous record. Okay, so now we have gone through all the intro and the prerequisites. Let's go on the meat of the topic. Yes, your data is late again. You are running out of time. You need to do something before your users complain. Okay, take a big breath. You're fine. You're going to be fine because you're here with me. Now, how do we deal with your late data? Let's go into our first layer of defects, preventing the downstream impact from your late arriving data. Okay, so your objective now is you have late arriving data. You don't want it to pollute your database, your data warehouse. You don't want it to pollute your metrics, and then your users will complain. Now, how are you going to do that as the first line of defense? So there are some preventive and proactive approaches that you can adopt to prevent your incomplete data from polluting your downstream reports. So generally, there are two types of approaches that we can do. Number one is doing a data reconciliation approach. And then the second type of pattern is that you can introduce data integrity checkpoints to find out if you have issues with late arriving data. So let's dive deep into those two approaches. Okay. Well, so what's data reconciliation? What's this big word that we are talking about? Okay. To put it simply, it's about comparing data from different sources to ensure three types of metrics. Number one, you want accurate data. And you want those values to be correct, not just in source A, but also in source B. You need your data to be correct. Number two, you need consistency. So what do we mean by consistency? If source A is saying that that customer has $20 in credit, but then you have another database which says that, oh no, this person has $30 in credit. Which one is the correct one? You have a consistency issue. And last but not least, you also need the data to have completeness. Because let's say you have data from source A, whereby you have data all the way until 13th of March, 4 p.m. But you have data from source B, whereby your data is last updated at, 10 a.m.? Oh boy, you have a problem. Now, how does a data reconciliation pattern look like? So this is an overview of how it looks like. So you have sources, and you load them into the staging area. And then after you do some raw data processing and cleaning up, you need to define matching criteria. And then compare the discrepancies. And once there is any discrepancies, you need to flag them. And flagging is not enough when you are only simply storing them for your internal use. This is a data source problem. You need to alert your users and your back-end team to do something. And this is where you need to connect your data reconciliation with messaging approaches like Slack alerts or email, because this is urgent. You need them to fix your data so that your users will stop complaining. Well, there are also some things that you can do if you are dealing with this kind of late arriving data streams. So there's this approach that is in the Databricks blog about how you can adopt a streaming reconciliation pattern. So there are three broad steps that you can adopt in a pattern. Number one, identify the late arriving data. So let's say you have late customer data and you have some transactions data already. You identify those transactions data as something that you want to retry later once your customer data is in. So that's the first step. Second step, you have those transaction data. You need to reconcile them, right? So because you keep retrying and retrying, then you're going to have a lot of duplicates in your reconciliation table. So you need to deal with those in a reconciliation table by duplicating and processing them. And after which, you feed those transactions data back into a retriable stream to reprocess them once you have more customer data. So you can keep retrying again and again until a certain limit whereby you decide, okay, the customer data is too late, we will have to discard it. Now, second approach is data integrity checks, whereby you can do some proactive checks to detect the arriving data. So you have the refresher integrity to check whether you have those customer IDs in the customer table in the first place. You also have some accepted values because who knows, you have some new values that you don't expect. Or you can also do this approach of, okay, let's just join the whole thing and just submit it even though it's missing. That works too, if you really want to submit it as an interim solution. And about data freshness checks, I mentioned that earlier. You need to have data freshness checks to know whether your data is going stale. Because otherwise, you don't know whether your data has been late for a day. Okay, so how do you implement these data integrity checks? Yeah, to summarize, there are data testing tools and frameworks that you can adopt, such as DBT. Like DBT, they have data tests. You can also use great expectations, or you can just build your own if you have the capacity. And remember that you can have data tests, but you need to remember to schedule them. So you can use schedulers like Airflow, which plays nice with DBT, or you can also use Dexter, which also plays well with DBT and other open source frameworks. And how do we implement those data validation checks and put them together? Okay, let's say you have those sources again. This is your customer data. This is your transaction data. This is, okay, so you have your, okay, this is your transaction data. This is your customer data. Notice something? 1, 2, 3, 4, 5 is not here. So what do? Define your criteria. Define whether so let's say you want to define whether foreign key in table A is available in B. In this case, it's not. So you have two choices. Either you send an alert to the system, which actually you don't have a choice. You should send the alert to the system. But you do have a choice on whether you want to continue the pipeline or not. But hey, this is important. We cannot afford to the 30-hour target table. So let's stop the pipeline. Okay, then so we go to the, so now we have done those prevention steps. Let's go to the limits of incrementality, also known as how far can we look back in time. Okay, anyone use DBT? Anyone knows this article? Anyone knows this discussion thread? Okay, for those who are not aware, it's talking about incremental strategy, especially when you're dealing with late arriving data. Firstly, is this table a fact or a dimension? This is something that you need to know first. Number two, when can you expect the late data to arrive? On average, or like most of the time. So based on those two information, you need to determine your look-back window approach to handle your late arriving data. Because you cannot keep looking back, right? You need to set some maximum delay that is allowed before you just ignore it. And why do we need to set this maximum? because there is this performance versus accuracy trade-off that we need to consider. Wait, so let's first look at the case for a late arriving fax. Example, I have payment transaction that is stuck in pending for more than 3 days. I have a lot of transactions. I have like 10 billion transactions, for example. And it can stay stuck for around 3 days before you have a final status of whether it's successful or failed. Well, it could be more, but on average, 3 days. So the design question we need to consider are, do we choose accuracy or do we choose performance? If you choose accuracy, which you might if you have small data sets, then you need to scan a wider date range, right? Because who knows, your payment may take 90 days to resolve, or maybe a year. Okay, if it takes a year, please don't use that vendor. Okay, so let's assume that you want to choose performance. But the thing is, you cannot have performance and accuracy at the same time, right? So there's a small possibility that you may have some late data loss from data which is very, very late. So how do we implement this type of pattern for late arriving fax? Pretty simple. You implement a look-back window of a maximum of, let's say, a certain acceptable window. It could be 3 days, it could be 5 days, it could be 7 days, depending on the distribution of how late your data arrives. Maybe take it as a 95th percentile, 97th percentile. Yeah, but your mileage may vary. Okay, the facts part is easy. But what if your dimension data is late? This is fine. You're with me, you know what to do. Now, the case is that your customer information data is late, and those are new customers. And the problem is that you have 5,000 customers that are impacted out of your 3 million records. Good luck. And you need to join both sets of data, your transactions and customer data, for your transaction reporting, because you don't want the bad guys to get away with it. So the design question in this case for dimensions is a little trickier. So if you are using slowly changing dimensions, especially your SCD2, which dimensions, so which time should we use? You want to use valid time or you want to use system time? You use valid time, then you need to hope that your system time is quite close to your event time. Because if your system time is much, much later than your event time, you will need to deal with a longer look-back window. That means you need to scan more data, which is more expensive. But let's say if you want to use system time, right? That's not great, right? Well, then you have a problem because your system time is not equal to event time. And if you do system time, it's not capturing real-world events either. So what do we do? So how do we handle late arriving data in this case? This is where we might need to do some custom incremental logic, because we also want to have those late arriving customer data to be included. So the design objective is that you want it to be performant and you want it to be close enough. So that's where you need to have some form of an event look-back window for both your transactions and your dimensions, your customer dimensions, so that you can also handle your early arriving facts and also your late arriving dimensions. And you need to do them incrementally. So if you look at this example, you notice that there is this change. So previously, it was mainly on the facts. Now you also add another filter to handle those late arriving dimensions. And you notice that we have some threshold window. So beyond that, we don't care. The time has already passed. But what if we want accurate data? We want it eventually accurate. Solution. Just do a periodic batch job. Let it run throughout midnight. Just let it run in the background. Problem solved. Okay, so far we are assuming that we don't really need to rewind. But what if we really need to rewind history on the data like your history on your data warehouse? It means I want the event time, I also want the system time. Imagine this scenario. You have audit once data that you have reported somewhere in the past. But then somewhere in the past, there was some issue with your data and you had to do some correction, but they are asking for data prior to the correction. So what do? Yeah, so this is the kind of scenario you have. You have some wrong data, then you need to deal with it. But you need to report what you have. You need to report the raw data you have reported. So how do we do that? This is where you need to deal with bitemporal models, unfortunately. So for those who are new to bitemporal, you are looking at both the valid time and system time, and you want to capture any retroactive changes in data over time. So the objective is to preserve your history, regardless of what happens in your event and in your system. So the objective is mainly for data governance purposes. So some implementations of bitemporal models, because that's not the main bulk of the talk, but you can look up on bitemporality if you're interested. So that you can do data snapshots of tuple versioning models, which we have mentioned earlier. You could do some history table for tracking state changes with system time partitioning. Or you could use change data capture and just keep capturing all those DML changes and then figure out how you're going to deal with it. And now we have gone through some of the techniques and approaches on how we can handle late arriving data. Here are some key takeaways. Number one, about late arriving data, we need to be proactive, not reactive. Hence, what I'd like you to take away from this talk is that we need to design proactive systems and models that can handle late arriving data to ensure data quality. And last but not least, we also need to manage accuracy versus performance trade-offs with window thresholds and also make up on the accuracy with periodic batch jobs. Because sometimes you may not be able to get accuracy now. You may be able to get accuracy later, but the most important thing that we need to do is impact, business impact. And even if your data is very accurate, if it does not provide impact, or if it does not provide impact, and you spend so much time on trying to make it accurate while it suffers in performance, you are not going to have a job, right? And ultimately, if your data is late again, and you are running out and you don't have a lot of money, which is currently the case in a lot of places, prioritize performance first. The accuracy can always come later. Thank you so much.
Are there any last question for Hwee for this interesting topic? Right.
Here are the slides. And here are the slides. And if you'd like to connect with me, here are my social media links.
Yeah. Hi, Hwee. Don't some tools like Snowflake or Databricks take care of the bitemporal because they do the auditing and they give you the history? But then my question here is, I guess if your data comes in late, even if you got that history and you try to go back in time for a snapshot on a certain, let's say, 1st of July, you're actually still missing the source record, right? So kind of, I guess the problem is still there intrinsically that you need to resolve the data kind of ingestion part. Is that my takeaway?
The main takeaway is that okay, you want accurate data, but you also want it to be performant, and you want to be able to fulfill your objective of delivering It's delivering your business with insights, business insights. So I think the trade-off is, so the thing is that you need to balance, like, when do you want to value accuracy and when do you want to value performance.
Yeah.
And yes, I use Snowflake, so I am aware of the time travel, although it's up to 90 days, but it's good enough for most cases. I think, eventually, like, it really depends on the industry.
Okay.
But in the financial industry, where you have some regulations and you also have, like, audit requirements, that's where they will expect some form of data governance and some audit logs. That means even if your data is wrong and you have to submit that as an interim, eventually the audit will still want to know, like, what have you submitted to the regulators.
I see. And so the tools, the tools, even if the tools get better, they're not necessarily going to solve for these operational issues which you've highlighted here, huh?
Yes, unfortunately, no matter how modern your modern data stack is, your business problems are still going to be evergreen.
Thanks a lot for the very insightful and informative closing talk, Hwee.
Thank you.
Yeah, we really appreciate your time. And thanks a lot for everyone for spending time with us for the first day of FOSSASIA Summit 2025. So this is the closing for today already. Hopefully you guys will have a great night today, and also hopefully you will have a great experience today. You learn a lot of new things, you met new people, have a new connection, and I hope to see all of you guys again tomorrow for the second days of FOSSASIA Summit 2025. Right, thanks everyone.